So in this section we're going to talk about different applications of percent, and we're starting with the applications of percent word problems. So what I'm going to do is I'm going to start with these word problems. I'll just read them out and we'll work through them together. So let's start with this one. The state of Rhode Island has an adult population of 837,000. How many of these adults might we predict will choose chocolate chip as their favorite ice cream flavor? Alright, well, if we look at this pie chart over here, we know that 32% of people prefer vanilla, 64% of people prefer all other flavors, and 4% of people prefer chocolate chip. So what I like to do is I like to convert this to is of percent sentence. So what I really want to know, and this is how I do these problems, I convert them, is what is 4% of 837,000 people? Because if I figure this out, I know what number of people will like chocolate chip ice cream. 4% of the 837,000 people like chocolate chip. I want to know what that number is. So if we make our triangle out of this, remember that the top of the triangle is my is, and that's what I don't know. My of is 837,000. My percent is 0.04. So once I have this, I know that I'm supposed to multiply 837,000 times 0.04. And you can go ahead and do that. And you're going to get 33,480. So what this tells you is that 4% of 837,000 is 33,480. So 33,480 people choose chocolate chip as their favorite ice cream in Rhode Island. So simple enough. So step one is just to make your equation into your problem into a is of percent type of problem, and then just go ahead and solve it. Let's try the next one. In Florida, about 34,000 new nurses were needed in 2006. If there are currently 130,000 nurses, what percent of new nurses are needed in Florida? Round to the nearest whole percent. So again, we have a problem that's kind of in a different form than we're used to. We have to make it into an is of percent equation. So I know that there are currently 130,000 nurses. So that's my of. And 34,000 will be new nurses. So I want to know what percent of 130,000 is 34,000. So let's go ahead and write it in that form. So what percent of 130,000 is 34,000? Alright, now that I have this, I can easily convert it into my triangle. So my is 34,000, my of is 130,000, my percent is unknown. So now that I do this, all I need to do is I need to divide 130,000 by 34,000. Because there are a bunch of zeros, you can cancel out all the zeros. And then you're really just dividing 130 by 34. I'm sorry, you're dividing, I should have written it this way. 130,000 is the divisor. 34,000 is the dividend. You can cancel out the zeros. And then you're really dividing 34 by 130. And you'll find out that that gives you about that. And it keeps on going forever. So if I'm rounding to the nearest whole percent, then I have 26%. So about 26% new nurses are needed. Okay, I will leave the next problem up to you. Let me just read it in case there's trouble with the recording. From 1994 to 2004, the number of registered vehicles on the road in the U.S. increased by 20%. In 1994, the number of vehicles on the road was 202 million. They want to find the increase in the number of vehicles on the road in 2004. So that's how many more vehicles we have on the road in 2004. They also want to find the total number of registered vehicles on the road in 2004. So I will leave that one for you to try. We do this the same way. Essentially, take the word problem, convert it into an is of percent equation, and then worry about going ahead and solving it. Okay, let me switch gears a little bit and go to percent increase, percent decrease. Okay, so we're going to use one formula, and that is that percent increase or decrease is simply the amount of increase or decrease over the original amount. So let's talk about what I mean by that. Let's start with this word problem down here. The number of people attending Peter Pan increased from 285 on Friday to 333 on Saturday. Find the percent increase in attendance. So I want to find the percent increase. Round to the nearest tenth of a percent. So I know the percent increase is the amount of increase over the original amount. So I know my original amount because it increased from 285 to 333. My original amount was 285. Now my amount of increase, well, that's just going to be how many more people there were on one day over the other. You go ahead and do that, and you're going to get 333 minus 285. So the amount of change was 48 people on one day over the next over 285. So you can go ahead and do this long division, and you'll end up with 16.8%. So that's the percent increase, is 16.8%. This is already rounded. I'll leave the math up to you. And I left an example here for you to try out that's very similar to the one we just did. A town with a population of 20,200 in 1995 decreased to 18,483 in 2005. What was the percent decrease? So you're going to use the exact same formula. And that formula is that percent decrease is the amount of decrease over the original amount. And there are some more problems that you can try out in your textbook dealing with this.